All right, hello, happy Thursday. Mr. Forden here, going to take you through your Thursday asynchronous assignment. Now, this is picking up on yesterday's Wednesday classwork that you had, classwork homework. You finished it up. I've already written back to a lot of you guys here on your new way of solving a quadratic equation. Now, we're going to look at this from the context of quadratic functions, so we will have a y hanging out there, but ultimately it's solving a quadratic equation, so we're going to be asked to find the zeros, which are otherwise referred to as the roots, which are otherwise referred to as the x-intercepts. And all of these, if we look at all these forms, they're all written in the vertex form. So yeah, we can definitely use that new method today, solving by taking the square root on pretty much all of these ones. And I say pretty much because the vast majority, we're going to run into some issues with one of them at least here. So these are in vertex form, and you have to use the method. Have to use the method that you were taught yesterday or attempted being taught. So I know that there might be some other ways to solve these equations, but I want you to learn this way because this is the easiest way. This is the easiest way to solve these ones, right? Don't need to mess around with some of the other things that you might know about here. And the only thing that we all know about as a class for solving a quadratic equation is the zero product property. We haven't learned anything else, okay? So try to keep with the class here, right? So that you're picking up everything, and therefore you can choose which method to solve later in the future because you'll know all of them, and you'll know which ones are fastest. And I'm telling you, this is the fastest if you have it in vertex form. All right, so number one, I got this one right here. Y equals x squared minus 24. Part A is what I mean here. This is in vertex form. Sure it is. Heck yeah. So I don't have a set of parentheses here, but I do have a perfect square. I have x squared. This is the same thing as x minus 0, right? The quantity x minus 0 being squared. Same thing as x squared. So anyways, I know that my vertex, for instance, is going to be at, where's it going to be at? Well, my y-intercept's not going to be at negative 24. Oh, it is actually, yeah, y-intercept here. So 0, negative 24, y-intercept. I'm going to put that on here. You do have to sketch these before you're good to go. Get them done here. All right, so there it is. I know I have my line of symmetry here, so now I just got to figure out my roots. Got to find out my zeros. So they're going to be equally apart here, right? Equally apart, equally away. Well, let's see what I'm saying. I'm getting at here if you don't want to get what I'm saying right now. So anyways, I got negative 24 there. Now I need to get my roots, my y-intercepts. Here, this is what you have to do in this assignment. You have to do this on a separate piece of paper. Okay, separate piece of paper. So anyways, I have it all set up. Ignore that right there. I have it all set up like this. Look, this is it. Here we go. We're going to do the solve by taking the square root method assignment together right here. But this is the kind of work I need to see from you. This is what I want you to practice. I want you to practice this new method here. We got 5. That's it. 5 problems today. Not too bad for a little classwork homework combination. Way less work than is in a typical year. You should wait till next year. Oh, no, I don't know about that. Yeah, high school isn't that crazy at the end of the day. It's not that nuts. All right, so let's check out this one. I want to solve for this one. What am I solving for? I'm solving for the roots. That's what I'm talking about here, the roots of this particular equation. So the roots of this polynomial here. So I got to flip my y to 0. There we go, because I'm getting x-intercepts. Then I got 0 equal to x squared minus 24. So now deep breaths. What do I do here? I think you know what to do. I simply need to isolate x. I start away from x right here, add 24 to both sides. And I got 24 over here. I got x squared right here. Perfect. Now I got x squared isolated. I want to figure out the value of x, though, that makes y equals 0. I don't care about what x squared equals to make y equals 0. I want to figure out ultimately what x is because that's what the x-intercept is. It's not the x squared intercept, which is not a real thing. Anyways, here, this is it. That's what it's all about. What do we got to do? We got to solve by taking the square root. That's right, take the square root. If I take the square root of both sides, I keep my equation balanced, but I also cancel out the squaring. Remember, a square root is the opposite, right? Opposite, this is the opposite of squaring. Okay, so if I want to get rid of a squaring, I do the opposite. I take the square root of both sides. Here's what you're going to forget, though, right? What we're going to forget, though, is, well, you might remember it when you actually have to go actually sketch the freaking graph right here. But the idea is my vertex is right here. I'm going to have 2 x-intercepts. One is going to be on this side of the y-axis. So keep in mind what I could say about my x-intercepts value over here somewhere. The other one's going to be the left side of the y-axis. Keep in mind what my values here. It's either going to be positive or negative, right? Positive or negative. Remember, there are 2 numbers that could multiply to themselves, right? Meaning one number can multiply to itself and become 24. There's another number that when multiplied to itself becomes 24. Remember, 25 is a perfect square. And what two numbers multiply to themselves to become 25? chunk of itself. It's like, so what's one number that multiplies to itself becomes 25? Well, 5. That's something called the principal square root of 25. 5 times 5 is 25. What else times itself is 25? -5, right? Because -5 times -5, 2 negatives become positive. Sure, 5 times 5 is 25. 2 negatives become positive. -5 times -5 equals 25. That works out well. So 24 is pretty close to 25. So my x-intercepts are going to be near 5, right? Near 5, but not exactly. It'll be plus or minus the square root of 24. And you can leave that as your exact answer. So anyways, next step of this, the way your book taught you yesterday was, I got to take a square root here. I got to do that. I got to introduce that here. I'm just what I'm trying to get here. So that means I know I'm going to have x's absolute value has to equal the principal square root of 24. Okay, principal square root of 24. That means that I got x equals negative the square root of 24. It could be that, right? Negative of whatever the square root of 24 is. Or x could equal the positive, right? It could be the positive times the positive outside the square root of 24. It could be that here, okay? So there it is. There's your answers right here. If you want to write your exact answers right here, be my guest. If you've done geometry at all this year, you probably know something called simplifying the radical expressions right here. This can be simplified. If you're a geometry student, you know you can actually simplify this expression to x equals, well, 6 times 4 is 24. So I can pull a 2 on the outside. This is 2 root 6. That's what it can simplify to. This could be x equals negative 2 root 6. But anyways, if you're not a geometry student, you'll learn that next year when you take geometry, simplifying square root expressions, right? 24 is just 4 times 6, and we actually take the square root of 4. It's 2. So anyways, just figured I'd show that to you here in a little nod to the geometry students here, okay? Anyways, these are my answers here for the roots, but you can also convert them, right? You can also convert them. Check this out here. You should see up here, I don't see it right now, but you should see on top a little scientific calculator. Let's see if I can get it to show up now. Is it showing up now? No, this is it. I want to save this here. Now it's there, okay? Let me get proof. This is what Mr. Fortin sees when he puts something like this together. I got a scientific calculator here. So I can hit that button. You can hit that button on your screen. You should see it. It's right at the top there. Look, scientific calculator. And I can do square root of 24. And there it is, right? About 4.89. I can put that in there. So that's going to tell you around where your x-intercept is. But actually, the roots, you can leave it in exact radical form here. Because look at this here. These decimals keep going. They're all changing numbers. They're all completely random. They all look pretty big. Well, there's a 4 there, and they're all completely big. It's actually something called, the square root of 24 is actually something called an irrational number. We don't know exactly what the square root of 24 is, because it's a bunch of decimals. The decimals keep going on forever. Square roots are kind of invented numbers to a certain extent. I don't know. You study them in the future. You study more math stuff, but I'm not getting into it now. So if you're not a perfect square, so if you're not like 4, 9, 16, 25, your square root only has a decimal approximation, right? Decimal approximation here. So what I would do is I would just leave your answers in terms of roots, right? In terms of the square root here. So I got square root of 24. And the nice thing is it tells you the rough decimal approximation. Here, I got negative square root of 24. Those are my 2 roots are. And it makes sense. About positive 4.89 or 4.9. About negative 4.9. Makes sense because then my line of symmetry is on the y-axis, and here it disappeared. I should have had my vertex at negative 24 and 0, negative 24. So that's my line of symmetry, and I got my roots at 5 point, that's about 5 or so, right? It's about halfway to 10. This is about halfway to negative 10. Sketching on in. Yeah, drawing on this. Drawing on this tool is a little, bulged out there. It doesn't look that good. All right, so that's what I'm looking for on this one here. And I'm looking for that you showed your work here. Let's do some more. Might as well. It's a new skill. It's nice to do them with you guys here. All right, let's do part B. I'll do them. Let's go. All right, let's check it out here. All right, so we got to remember Ramon was telling us, what Hermione was telling us, what, who else was Olivia Granger was telling us here. Well, we got to solve this here. How do we solve for roots? We got to change the value, find the value of x when y equals 0. There we go. Those are our zeros. Those are our roots. Those are our x-intercepts. We need to find them. All right, so I'm going to just recopy this. I want to just flip to 0. Now we got to solve, my friends. Let's do it. Okay, so I got x here. What did Hermione say? All right, I want to isolate that x. I got to start taking away the garbage that's like away from the x here. Let's not get preoccupied with things that are happening as x, and 2 taken away from it, then it gets squared, then we multiply it by 3, then we subtract 5. Let's just do something that isn't really going to be that close to what's happening next. Let's get rid of it first. So let's get rid of that -5, okay, shall we? Let's add 5 to both sides. Okay, I got 5, so you're doing this. You can do this along with me. You can do this on your own. We got this, though, right? Doing this new process. If you can get it, you can get this really quickly. You'll make a few mistakes here, okay? 5 equals 3 times the quantity of x minus 2, but it's being squared here. Okay, what's away from the x? Well, x gets 2 taken away from it, then it gets squared, then it gets multiplied by 3. That'd be the last thing happening in x, so let's get rid of that now, okay? Instead of multiplying by x, let's divide both sides by 3 to cancel out that x. So now I got 5/3 over here, and I got x minus 2 squared, okay? So the 2 gets taken away from x, but then the whole thing gets squared, so what do I gotta get rid of next? Now's the time where I introduce the square root, okay? Square root both sides, but what do you remember? What do you have to do when you're putting in that square root? What do you have to do? Well, you have to remember that this here, x minus 2, could have been a negative number, right? Could have been a negative number. So I'm going to put the absolute value bars around x minus 2 because x minus 2 could have been a negative number that when multiplied to itself became 5/3, or it could have been a positive number that when multiplied times itself to become 5/3 here. So here I need to put the absolute value bars in. I do. Now I get absolute value of x minus 2 equals root 5/3. Whoa, that's messy. Okay, that's messy here. So anyways, what I need to do now is I need to break this up into 2 equations. Now this is getting really messy, especially because I probably want to do these problems with you. Maybe I can move them down. Hold on a second. Let me move them down. Yeah, there we go. To make some space. Yes. Ooh, that was not messy. That was not good. I'll just erase those parts. Okay, check it out here. Let's erase it. Erase right here. Erase right there. There we go. Okay, so let's keep going on this one because this is messy here. Okay, I got to create 2 equations. Okay, so remember, I could have the negative of the square root of 5/3. That could represent x minus 2, but also the positive of root 5/3, of the principal square root of root 5/3. That could also equal x minus 2. So you're going to have 2 solutions, right? One's positive, one's negative at least. At least it seems like the case here. And now let's solve for x. What do I got to do to both sides? Add 2 to the right side, add 2 to the left. That'll cancel out that minus 2. And then I get 2 minus root 5/3 equaling x. There is one of my x-intercepts. Ooh, that's messy though. Isn't it messy? And then I'll add 2 to both sides over here too, plus 2. I got 2 plus root 5/3. That equals x. That is my other root there. So is my line of symmetry at 0, 0? No, not really. Right, because root 5/3 will like 5/3 is about 2. It's like 1 2/3. So, anyways, it's probably about 1.4 or so. I don't know, a little less than 1.4, 1.3 if I set approximate decimal answer. So I got about 1.3 plus 2 is about 3.3, and then 2 minus 1.3 is about 0.7. So they're both positive. Actually, both the roots will be positive. Both the x-intercepts. Anyways, zeros. Just type in your exact radical answers or exact square root answers here. So write your answers in exact radical form, okay? So that's all you got to do is put this here, and we'll leave the square in the answer. 2 minus root 5/3, and then we got 2 plus root 5/3. And there we go, about 0.7 and about 3.2. How about that? It's like as if I teach math or something. Bad. That was a terrible joke. All right, anyways, let's go ahead and do it. So we got our roots, very nice, and approximately 0.7. So let's check it out here. So I got this is scaled very nicely for me. Oh, that's so nice, so thoughtful. It's about 0.7 here. About 3.3 is what we want. So 2, 3, and then here. There are my roots. Do I know my vertex? Sure, I do. Look at that. Vertex there, 2, -5. And yeah, line of symmetry at 2 kind of makes sense. So we have the line of symmetry makes sense. These are like weird decimals, okay? Weird decimals here. So this one is not factorable, my friends. Not factorable because we have weird decimals as our x-intercepts. These are called irrational numbers. You actually learn the definition of irrational numbers in Algebra 2. But anyways, 2, -5 is my vertex. And look at this. What a gorgeous parabola sketch. It's going to keep on going up forever. Okay, domain is all real numbers. Range is everything above -5. And we got some roots there. One root at 2 minus the square root of 5/3. Wow, that's a really specific number. And 2 plus the square root of 5/3. So approximately these. All right, you getting the flow of things here? Let's do it. Let's do it more. Let's do it, okay? All right, I might skip D. Maybe we won't do D, but I want to do E with you. Let's do E, okay? So definitely check out D. Make sure you got D right when I'm checking over your answers. But let's just do one, like this one, and then let's do that one. Let's check it out here. All right. Anyways, getting roots. That's all we're doing. Getting roots, getting zeros, getting x-intercepts. So I'm going to replace this with 0. Then I'm going to solve, right? Solving a different looking equation. Good times. This is your main solving of the year. It's come quadratics. Yeah. Okay. Start furthest away from x as possible. I'm going to take 3 away from both sides. So now I'm going to have -3 on the left. Uh-oh, even negative on the left. That's okay, I have a negative right here. You'll see why that's important later on, hopefully, in my discussion with you. Okay, now I'm still going to start away from x. X gets a 4 added to it, and then it gets squared. Last thing that happens to it is that it gets multiplied by -2. So let's get rid of that. Let's get rid of the last thing that happens to x. So we simplify by undoing the expression that we have over here. -2 divided by -2 is just 1. Right? Anything divided by itself is just 1. This is -3 divided by -2. So -3 divided by -2, that's the same as 3 divided by 2, because 2 negatives dividing is the result's going to be positive. So I'm going to have positive 1.5, and I can do that too, right? Because 3 divided by split 2 ways would give you $3 split 2 ways, everybody gets $1.50, right? 1.5 is going to equal x plus 4 squared. Okay, make some more space. Maybe I'll actually move the E over here because I do want to do E with you guys. Let's just keep working it out. Make sure we got it here. All right, what are we doing to both sides? We're taking the square root of both sides now, friends, at this point. Take the square root there. And remember, to get to 1.5, it could be a negative number squared that gets you to 1.5, or it could be a positive number squared that gets you to positive 1.5. Any positive number, they have 2 square roots. One negative number, and then its opposite, one positive number. Okay, 9 square roots are positive 3 and negative 3. 4 square roots are positive 2 and negative 2. The positive of the square roots is called the principal square root. So 36 has a principal square root of positive 6, but then it also has an opposite square root, which is negative 6. Negative 6 is actually 36. Okay, so anyways, 3/2. This is going to be an irrational, because this isn't a perfect square. You can't really take the square root of 1.5, but you can get an approximate answer of something that would multiply to itself that would be 1.5, okay? All right, so we do this, but this is where you got to remember, you can't forget this, right? I always think people forget this. Why I ask you these questions past 2 days. What do you think you're going to forget? Well, I know that I'm going to cancel out the squaring, but what I got to remember, well, this here, we need the absolute value of x plus 4, because it could either be the negative of this, x plus 4, or the positive of x plus 4. That, when multiplied to itself, became 1.5. So this is now how I'm writing my equation. Okay? Next, what am I going to do? I'm going to break it apart, and I'm going to do, well, let's do the negative version first. Negative 1.5 is square root of negative 1.5 equals x plus 4. I'm going to subtract 4 from both sides, and I got negative 4 minus root 1.5. And the other one, I actually can figure out the other one without even doing it out, showing the work like this. So, because once I have this here, what's going to be the one thing that's going to change? That's it. That's just going to be a positive here. So I'm still going to subtract 4 from both sides to isolate x, and I get negative 4 plus root 1.5 equal to x. And there we go. There are the roots. And with that, we got our x-intercepts here. So let's go ahead and put it on in. And then we'll wrap up with doing part E, because part E is a nice one. We get to think about a few more things that maybe we haven't really fully considered yet. Negative 4 minus the square root of 1.5. Let's go. There we go. And positive 4. No, negative 4 still. Negative 4 plus, right, the square root of 5. So sort of our answer here is negative 4 plus or minus the square root of 1.5. Plus or minus. There's actually a plus or minus symbol that I need to show you guys at some point here. Anyways, plus the square root of 1.5. Because, yeah, you could abbreviate your answer as negative 4 plus or minus the square root of 1.5. And then you don't have to write as much. if you're good at reading it, plus or minus means, oh, we're going to split them apart. We'll have two answers, but we can write the answer in just like one statement. But anyways, here we go. So now, yeah, we just look at this. Get the decimal approximations here. Decimal approximations. We've got negative 5.2 or so. Oh, well, I'll just say that's right there. Why not? And we got negative 2.77. Okay, negative 2.77. There we go. Vertex, negative 4, 3. Ah, yes, so it's downward facing. That's right. I should have maybe said that already. Yeah, my A here is negative. It's pretty thin too, huh? It looks pretty thin, so I think we did it right. I think this is good to go. There we go. Downward facing. Maybe it's a firework getting thrown in the air. It's exploding where the vertex is, and then we're just tracking the rest of the trajectory here, okay? And then that is your third example, okay? I think you got the swing of this thing here. I'll let you do D all by yourself, okay? Even if you're watching the video, you should be able to know D all by yourself now, okay? But message me if you have any questions. Part E is a good one, though. I want to do Part E because, hey, I know I'll get questions about it. What do I do in this one here? It gets slide all to itself. So check it out. What am I going to do about Part E? Well, let's do the same thing we do every day or every time. Flip it to 0. And why is Mr. Forden feeling the need to do this one? Doesn't this feel just like what we just did? Negative 2 equals 1/2 x plus 3 squared. I get it. Well, the 1/2 thing, to get rid of that, instead of dividing by 1/2, what I should just do is multiply both sides by 2. So I guess that's part of the reason why I'm showing this to you. So whatever you do to one side of an equation, you got to do the other. So multiply one side by 2, multiply the other side by 2, and I get negative 4 equals x plus 3 squared, okay? Here's where the issue comes. Check this out. Well, I want to get x plus 3, not x plus 3 squared. What can I do to both sides? I can take a square root. Tell me what's wrong about this. I went too far. Here. There we go. What's wrong about that, friends? What's wrong? Negative 4. What's the square root of negative 4? Well, the square root of 4 is 2. Another square root of positive 4 is negative 2, right? Because negative 2 times negative 2 is positive 4. So then what's the square root of negative 4? What two numbers multiplied to? So they got to be negative, right? Oh, wait, no. A negative times a negative would be a positive. So, wait. Is it possible to take any real number and multiply it to itself and it would be negative 4? Okay. No, there aren't. No, there aren't. So here, check it out. There are no real roots. Okay, no real solutions to this problem here. Okay, so when you get a negative, you have to take a square root of it in an equation. For now, but later, potentially, I don't think this year we'll get to it. Algebra 2, you get to it. You have to do some other stuff with the imaginary numbers. Okay, but for now, all we're saying is, can't do it. This is broken here. So it turns out, using this vertex form, we can't actually solve for the x-intercept. Wait a second, I thought that was the whole point about what we've been doing the past 2 days, because zero product property gets it to you if you're in factored form, gets to the x-intercept. So I thought the idea is we're doing this new method. We're studying solving by taking the square root to give me the x-intercepts, because sometimes things aren't factorable. So I can, if I have it in vertex form, then it doesn't matter if it's not factorable. I can solve for it. Well, let's take a look. Let's take a look at the graph and see if we can deduce exactly what it looks like here. So anyways, you're going to have to kind of explain what kind of happened in a second. I won't do that for you. What happened on part E, explain it. But here, right here, the roots are, okay, I'm going to put this, no real roots or no real solutions. No real solutions. There are imaginary solutions, which you won't actually see on the graph because they're imaginary. But let's check this one out here. Let's maybe look at this graph. I'm actually going to graph it. So first of all, where's the vertex of this graph here? Real quick, actually, you could have saved all your work here if you actually thought about this for like, you're going to figure this out in 20 seconds here. Where's the vertex of this graph? Vertex is at -3, +2. So I'm going to go to that, -3, +2. And guys, where does this graph open? Does it open up or does it open down? Because it would have to open down for there to be x-intercepts, for there to be real roots, real number roots here. Look at that. What do we know about positive 1/2? It's going to open up. It's going to open up. So this guy does not have any x-intercepts here. So a vertex form shows you the vertex, shows he's going to open up. We're not going to be able to solve this. We're not going to be able to solve this roots because there are no real roots. It's not actually going to hit the x-intercept. We can actually graph this one, though, by figuring out what the y-intercept is. I saw people doing this yesterday. I thought this was good. So let's figure out, let's probably end this video about getting the y-intercept of this one right here, of part E. Part E, so that we can actually finish graphing this one out. Check this out. Just bear with me for another 4 minutes, maybe. 4 minutes, okay? 0, well, I don't want 0 with the y-intercept, so I want to make x 0. So actually, yeah, this is probably, I could have changed it to standard form. That would have been one way, but I'm going to get this is I'm just going to plug in, right? Plug in 0 for x, right? Because remember, the y-intercept's the value of y when x equals 0. So I'm going to figure out the y-intercept by taking this, right? Y, let me just get the whole function down here. Okay, now I'm going to plug into this function in output. I'm going to give the output. I want my output for, wait, no, never mind. I want my input. My input of x to be 0, figure out where along the y-axis it has to be when x is 0. So y is going to equal 1/2 times by 0 plus 3 squared plus 2, and then I get y equals 1/2. 0 plus 3 is 3, right? Square it, you get 9. Okay, so remember, PEMDAS is your rule here. PEMDAS is your best friend, order of operations. What do I got to do? Well, I got to clean up my parentheses. 0 plus 3 is just 3. Then I got to think about exponents because it's PEMDAS, parentheses, exponent, multiplication. So parentheses and then exponents. So this is 3. Exponent is 3 squared. That's 9. Now I got to think about multiplication next. So I got to do the 1/2 times 9 first. And I get 1/2 times by 9 is 4.5, right? It would just be 9 divided by 2. That's 4.5 plus 2. And then I get 6.5. So my y-intercept is at 0, 6.5. And this is just going to reinforce the fact that, here's 6.5 right here, that this isn't going to have any x-intercepts here. I open upward, and with some symmetry, I can get a pretty good sketch of this. Okay, let's try to get the sketch of it here, shall we? Something like that. Right, something like that is how this parabola is going to be structured. And then it's going to turn around, and then it's going to be symmetrical. Oops, it kind of looks like the vertex is a vertex there, and then flip around. Something like that. Okay, something like that. Yeah, it's pretty ugly. Not my prettiest graph, but it is what it is. The important thing is no x-intercepts here. That's why we couldn't solve it. Couldn't solve it using the square root method. We have no real roots, therefore there'll be no x-intercepts presented to us on the graph. Okay? Thank you for watching. Hopefully this didn't put you to sleep. It is what it is. Keep trying as hard as you can and keep learning, man. Learn sweet. Exercising those brain muscles while we can before we disperse for summer. It's coming up soon. All right, message me if you have any questions. Take care, guys. Bye.